number 3 is a composition function problem, and we also want to pay attention to the domain. So we got to be really disciplined remembering our steps on this. So I'm going to kind of outline our steps. Number 1, we want to find the domain of our input function or our inside function. We want to do that right away. We don't want to forget that. Remember, we want to keep this domain. Second thing we're going to do is once we figure out what that domain is of the inside function, we're going to compose our two functions. So we're going to find the composition. Third thing is we're going to find the domain of our new function, which is the composed function. We're out of room there. So find the domain of that new composed function. And fourth, what you got to do is you got to compare or find the overlap of your two domains that you found. The overlap, another way of saying that is, what you want to do is compare your two domains and use the most restrictive set or domain. I'm going to demonstrate what I mean by that. So, number 1, we're going to find the domain of the inside function. Then we're going to compose the functions. Then we're going to see are there any new restrictions on our domain and our composed function. And then we're going to look for the overlap, or we're going to compare the domains and see what is the most restricting domain. So that's my outline. That's my plan. So number 1, my inside function, since it is g of f at x is going inside. So what I want to do is I want to make sure I find the domain of f at x. Well, f at x is the square root of x plus 6. And what we've learned and what we've rehearsed is we don't want to go outside the real number system, so we want to make sure that our x plus 6 ends up being greater than or equal to 0. This has to be 0 or larger. So that means x must be greater than or equal to a negative 6. So this is the domain I'm going to keep out of step 1. Step number 2. Outline that as step 2, step 1. I'm going to compose the function. So now I'm going to put inside function g, function f, which is x plus 6. And function g is defined to be the square root of 16 plus your input squared. So what I'm doing is I'm taking out this x and I'm replacing it with my input of the square root of x plus 6. So it's 16 plus the square root of x plus 6, and we're going to square that. So that equals the square root of 16 plus, when you square a square root, they're inversely undo each other, so it's x plus 6. Now we want to collect our like terms underneath the radicals. So this is the square root of x plus 22. This is our composed function g of f at x. So I just got done with step number 2. I've composed the two functions. Step number 3, I want to find any added restrictions to my domain. So what is the domain of this new function, f at x? So step 3, I'm going to look at the composite function, which is the square root of x plus 22, and I want to be looking for its domain restrictions. And does it have any? Well, we want to make sure that x plus 22 is greater than or equal to 0, which means x must be greater than or equal to a negative 22. There's my second domain restriction. Here's my first domain restriction. So in step number 4, I'm going to compare these. So down in step number 4, I had one domain restriction that said x had to be greater than or equal to negative 6. The second one was x is greater than or equal to a negative 22. And illustrate this a couple different ways. Number 1, I could show you on a number line what these domains look like. So I'm going to take this first one. X has to be greater than a negative 22. Greater than or equal to, solid dot, moving to the right to all infinity. As long as we choose values that are greater than or equal to negative 22, it's defined. The other domain restriction was make sure you choose numbers that are greater than or equal to negative 6. So here's my negative 6 greater than or equal to. And my new domain, the domain that we want to use for our composite function, is the overlap of those two. So there's our overlap, which means our domain for our new function, I'm going to go back and look at the directions. It was in set builder notation. So the domain is going to equal a set where we look at our input values, which are elements of the real numbers, such that our overlap, sitting right in here, was making sure that our x phase had to be greater than or equal to a -6. In set builder notation, that is our domain of our composed function, which was back at the other step up here, x plus 22. So those are the two different things that we're looking for. I said I'd look at this domain in a couple different ways. Here's our overlap. The other way is to look at these two restrictions and say which one restricts it the most, which one has the greatest restrictions on it and uses fewer x values, and that is when x is greater than or equal to -6. So always find the most restricted domain for your composite functions, and you'll be golden.